So review for Summative 3. We're going to have quite a few old topics on this Summative. The newer topics show up at the end, so if you need to skip around, that's totally fine. But this is an old topic of solving linear equations. So we haven't seen this for about 3 weeks, but you guys have been doing a really nice job with knowing how to distribute. Sometimes we get a little sloppy with simplifying. So this becomes a 14k plus 28 equals, the negative 3k is still here, but then distributing the 5 would be a plus 5k minus 20. We suggest that you clean up each side of the equation before you move across. So across the sides, so negative 3k plus 5k would be 2k, whoops, minus 20. And then still equals 14k plus 28. So then make your own decision here of where to bring the k's. Most of you like to keep them positive, so you're going to probably subtract 2k. And because you're going opposite sides, you got to use opposite operations, and you're also going to move the constant over by subtracting the 28. So we end up with, let's see, that's 12k. These are gone. Equals, these are gone. Negative 48. And then our final step is we're going to divide both sides by 12. And we get k equals negative 4. So, multi-step equations, you guys are doing a fantastic job with the process and the concepts. Just need to be a little less sloppy at times. So we're going to distribute a negative 4 here. Now be careful, here you're distributing like a negative 1. So this becomes a negative 4x, this is a plus 8, equals 7 is still here, but then this becomes a minus 5x, and then a minus 7. So cleaning up some like terms on each side, the 7 and the negative 7 are actually going to end up canceling each other. So when you look at your leftover equation, negative 4x plus 8 equals negative 5x, you're going to want to bring the x's to one side, so the easiest way to do that would be to add this 4x over here. Alright, so almost home free here. We end up with 8 equals, careful on the negative, this is a negative 1x. So then dividing both sides by a negative 1, we find out that x equals negative 8. If you've ever received a note from me on a summative or worksheet about like slow down or, show that step so you stop making that mistake, right here where I have the green ink, that's the place where kids have mistakes, and I know you're not intending to do that mistake, and sometimes you don't. But the problem is if you don't show that step, you're going to keep making that mistake. So for 3 and 4, we have cross product questions. We have proportions. So you're going to cross multiply them, which means you take this diagonal and multiply it together. So the 6 is being multiplied by x plus 3. And then similarly, you do the other diagonal, and then you set them equal to each other. So 3 is being multiplied by 3x minus 1, and these have to equal. So we're going to distribute the 6, we're going to distribute the 3, and you get 6x plus 18 equals 9x minus 3. So now that we're fully distributed, let's bring all the x's to one side. Let's go ahead and subtract 6x. If you brought the x's to the right, that means the constants are going to move to the left. So, let's see here. 21 equals 3x. So dividing both sides by 3. Woo, that's ugly. 3. I found out that x equals 7. Alright, move it along to the next cross product. Same idea, guys. We're just going to multiply each diagonal. Some of you like to skip a step and you go ahead and you distribute right away. That is cool as long as you are doing it effectively. So like 3 times x minus 1 is 3x minus 3. If you want to skip to that step, you can. And then 2 times 4x plus 3 is an 8x plus 6. So if you want to skip that intermediate, like distribute next step, you can. I just don't like when you guys do things like that on a test and then you're sloppy and you get it wrong, because if you don't show your work, I can't give you feedback and I can't give you that good score that you deserve. So x is to the right this time. Let's go variables to the left. So we end up with, careful, that's a negative 9 equals 5x. And then another mistake I kept seeing from a few of our friends was the dividing backwards. You're dividing by the coefficient of the x. Show that step so you can see what's canceling. X is negative 9/5. That is your answer. If you tried to reduce that on your calculator by hitting math under enter, it would just come back to 9/5 for you. So 5 kind of looks like a proportion, but I wouldn't cross multiply anything yet. And some kids say, oh, I'm going to multiply everything by a 5. You can, but you'd have to multiply every single term. So this one plus this one and this one. So instead of multiplying right away, whoops, erase. How about we go ahead and we move the 4 over by subtracting it? I think that'd be a better move. So we have 2x minus 1, that whole term being divided by 5, and it equals a 9. So now if you want to think of it like a cross multiplication question, you can think of it as a proportion, or a lot of kids just tell me, oh, Bruzo, I know to multiply by 5 on both sides of the equation. Well, that's exactly what cross multiplying is, and you're actually doing it mathematically properly. So these 5's cancel each other out, so you just have 2x minus 1. And then over here, 9 times 5 is a 45. So then, of course, we're going to solve. We're going to start by adding the 1 over to the other side. And then eventually you're going to divide by 2. So a couple of steps later, we find out that x equals 23. Very nice. The next question, very similar in style. I would move that kind of outside term first. So I would go ahead and I'd add that 9 over. So now you're looking at 4x plus 3, that whole term being divided by 2, and it equals 16. So if you want to cross multiply 2 times 16, that's fine. Or if you want to think of it as I got to multiply by 2 on both sides, that's actually the proper way to do it. So these 2's cancel, and you're still left with 4x plus 3. And then 6 times 2 is a 32, and now we have a nice equation to solve. So remember in Algebra 2, I usually make up these questions off the top of my head when I'm making up tests, because I make up a lot of different versions and things. They're not always going to come out to nice answers, so don't panic when you keep solving them and you keep getting fractions. Like, you're probably going to get a lot of fractions on here, and that's okay. What do we get, 29/4? Awesome. Alright, and then the dreaded LCM questions, huh? So, I was keying this one, and I kind of caught myself in a mistake. I was looking at 35 and 7, and I got all excited. I was like, oh, 35 will work. And then I started to distribute the 35, but I ran into trouble right here with the half, because 35 and 2 won't work. So I got to go bigger than a 35. So if I incorporate the 2 into that, what if we go with a 70 for our LCM? So everybody here is going to get multiplied by a 70, including the things that don't look like fractions. So that 7v is still going to get multiplied by 70. Even I had to use my calculator on this next step, guys, because I was not thinking straight. So 70 times this fraction is a negative 1112. And then plus 35v equals 490v plus 240v. And I know that doesn't look a ton better, but at least there's no fractions. So we can combine our like terms over here on the right-hand side. Smushing those together, you get 730v. Equals negative 1112 plus 35v. Okay, bring v's to one side, so the easiest way to do that would be to subtract this 35v over here. And then, when you get to the division step, please do show it, because some of you are still dividing backwards. So we're dividing by the coefficient of 695. And I am going to type this in my calculator. Even your math teacher had to type this in her calculator, guys. And then I'm going to hit math enter on this fraction, because I'm pretty sure that reduces. And I think it reduces to negative 8/5. I do not expect you to do fraction reduction in your head with numbers that big. No way. I mean, we could, but I don't expect it. All right, this next one, 5 and 15 and 4. Well, 15 is kind of a problem, because his multiples are like 15 and 30 and 45 and 60 and so on. So I think I just found out a common multiple that'll work. Let's try a 60. And the idea with a common multiple, it doesn't have to be the smallest common multiple. So if you really get in a jam, just multiply all the numbers together, and that number will work. You're just going to have really big numbers. So when I distribute this 60, I get 204x plus 60 equals negative 232 minus 15x. And then I got this nice couple-step equation where I can just bring x's together. So I'm going to add the 15x over here. While I'm at it, I'll go ahead and subtract the 60. And I had a kid the other day who said, oh, I really like the way, you know, the notes look on the slides, because they're all color-coded and everything, and all the steps look really nice, and I can follow it easily, and I don't make mistakes. But when I use pencil, you know, I make a lot of mistakes, and I do things weird. And I said, well, why don't you just do your problem in color. So I have absolutely no problem with you guys busting out the markers and the highlighters and the colored pencils. If that makes you happy, go ahead. Alright, these are going to cancel, and you get x equals math enter this, comes out to -4/3. Alright, so that's a new score on that section 1.4 part 1. Everyone's getting a new score. Also, everyone's getting a new score here on graphing systems. Now these two examples for graphs are going to be like your slanty diagonal lines, but remember, if you ever run into like x equals a number, like x equals c, that's a vertical line through whatever that number is. And if you ever run into y equals c, y equals some number, that's a horizontal line. So just kind of keep that in the back of your brain whenever we're graphing lines. Sometimes those special case lines pop up. They just don't happen to pop up here. Both of these lines could be written in y equals form. So I'm going to solve for this y by subtracting the 1 over here. So y equals, if you subtracted 1 over, you'd have -4x plus, oops, not plus 1, minus 1. That was dangerous of me not to show the work. I suggest on your test to actually show the work. So let's graph this line. Oh, geez, I missed my line. -4x minus 1 starts at -1. And then your slope of -4 over 1. Usually I'd move down 4, right 1. I'm going to run out of space though, so how about we move up 4, left 1. And we end up with kind of a line. Remember, these are supposed to come out beautiful, so let's see. This line's a little bit backwards. You don't have to move any terms around, but they are kind of backwards in as far as the order of graphing. So x plus 4 would start up here at 4, and then your slope is 1 over 1. So we could travel up 1, right 1, and down 1, left 1. And then our functions will intersect at that ordered pair, which is at the location -1, 3. So we have to move around some terms here on this one as well. Let's try to get this y isolated by, let's start by subtracting the 2 first. So 4x minus 2 equals -2y. And then a final step here would be to divide everything by a -2. Let me switch colors here so it doesn't look so terrible. And you want to simplify them separately. So this line becomes y equals, simplify here, -2x and then a plus 1 when you reduce that negative over negative. So we'll graph that in a minute. And then this line also, you got to solve for y as well. That was a lot easier to solve for. You just subtract the 2 over. So like x minus 2 equals y. Alright, so blue line. Let's start at positive 1. And then your slope is a -2 over 1. So you're going to travel down 2, right 1. Or you can move up 2, left 1. Either way, that's a negative line. Oh man. Kind of missed. Kind of got it. And then my green line, right here, starts at -2. And then has a slope of 1 over 1. So I'm going to move up 1, right 1. Boom. Found the intersection. Right. Oh, man. Alright, so, oh, jeez, it just got really ugly. Alright, so this intersection point right here, this is the location 1, -1, and that's the solution I need. So remember, if you end up with two lines that are parallel, there is no solution because they will not intersect. So just keep that in the back of your mind when you are testing graphing systems. Okay, now I'm going to ask you to solve by substitution. And substitution is the one where you put the box around the recipe and then you like plug it in somewhere else. So the problem is there's no recipe. So I look through my system for the easiest variable to isolate, which would mean the one that has a really small coefficient. So like this dude right here would be easy to isolate. So leave x where it is, subtract the 2y over, and you can write it as 18 minus 2y. I'm okay with that. That is the recipe that we're going to use, and we're going to substitute into the other equation. Boom, right there. So that top equation, 4, but we're not using x anymore, minus 4y equals 12. And the 18 minus 2y is what we place inside for x. So go slow, because these are easy to mess up, and just remember that these always come out really pretty, so if you get a weird answer, try again. Let's see, what is that, 72 minus 8y? Usually when I make that little comment, I mess up, so let's see. All right, equals 12, and then combining our like terms over here, like right here, I mean, that becomes 72 minus 12y equals 12. Let's go ahead and subtract that 72 over. Oh my gosh, I think I did mess up. Or no, I didn't. I was just looking at the answer key. I was looking at the wrong one. Alright, so we have negative 12y equals negative 60 when you divide both sides by negative 12. And I had a lot of kids like dropping negatives when they're doing their math, and that's heartbreaking, right? So you just found out that y equals 5. Make sure that goes in the proper part of the ordered pair. It's y equals 5. And what I like about substitution is that thing you boxed in, that's a recipe for x. So 18 minus 2 times y, which y'all just found is 5, that would be 18 minus 10, so that would be an 8. So ordered pair is 8, 5. We got this from right there. Okay. So same idea on the next question. You look for the easiest variable to isolate. I'm thinking this one right here. That would be the easiest one to isolate. So I'm going to rewrite that as y equals, just add that 4x over. Oh, that's kind of wonderful. So we're going to plug in 4x. Hello. Everywhere we see a y in the other equation. So boom, right there. So this equation becomes negative 8x plus 2 times y, which we know is 4x, equals 0. Let's clean this up a bit. Oh, this is a weird one. Negative 8x plus 8x equals 0. These end up canceling each other, and you get this weird statement, 0 equals 0. Now that is true. 0 does equal 0. So this is the one where you have infinitely many solutions. If you get the x's to knock out and it's like a gibberish statement, like 0 equals 5, that's when it's no solution. Excuse me. Alright, so now we're going to solve by elimination. It must be elimination, the one where you cross off one of the variables. So whether it's x or y, I don't really care. It's up to you. So when I look at my variables and trying to choose who I'm going to eliminate, I look for small numbers. And also, if anybody already has opposite signs, that's pretty awesome, because then I don't have to worry about signs. But I don't really have either of those things. So I'm going to try to figure out how to eliminate the y's. And I'm basically just going to multiply them by each other. But here's the kicker. I can't just multiply this top equation by a 6 and the bottom by a 5, because they're still going to have both positive signs. So I have to make one of these negative, and I like to make the bottom one negative. So my new system, if I distribute the 6 all the way, I get, let's see, 120x plus 30y equals, oh boy, 26 times 6 is 156, I think, but let me check it. Yeah, 156. Go me on a Monday. Alright, 156. And then down here at the bottom, I'm not even going to guess that one. Negative 120. Oh boy, this is going to be a weird one again. Minus 30y equals, and you do have to go through and figure this out, although didn't I just type this? Isn't that negative 120? Alright, so the reason this is a weird one, they're both canceling, which is not supposed to happen every time. 0 plus 0 equals like 36 or something, right? So 0 does not equal 36. That's bogus. So we say this is no solution. So over here, when I'm looking at who to eliminate, I notice the x's already have opposite signs, so I'm going to focus on trying to knock those out, because then I don't have to worry about signs. So I'm just going to multiply them by each other. So this guy's going to get a 2, this guy's going to get a 5. They're both going to become 10s, although one is already negative. So I get a 10x minus 8y equals, go all the way with this, minus 10. And then distribute here, so you get negative 10x minus 30y equals 10. Now, do not panic. At first glance, you're like, 38, that's weird. But then it equals 0. And remember, 0 is a number, so when you divide both sides by negative 38, you do end up with y equals 0. So when you go to write your ordered pair for me, you put 0 in the y position. Now you take your favorite equation, which I like this bottom one here, and you plug in a 0 for the y term right here. So negative 2x minus 6 times 0, which would be 0, equals 2. So this term's totally gone. Divide both sides by negative 2, and you get x equals negative 1. So elimination is probably the one you guys all like the best. I don't know why. It's definitely not my favorite. Alright, so here I just need you to set up your system and clearly define your variables. So we have to get in the habit of jumping straight to the end of the question and looking at the actual question, because that's your variable. That's like a shining light for all your variables, guys. It says, what is the price of one senior citizen ticket and one student ticket? So when you choose your variables, that's what they are. So I kept having you guys tell me the wrong variable usage on the last question, and then I would write like what about it? Or I'd highlight this part. So X could be the price, or the cost, if you'd rather say that, of one senior citizen ticket. That works for me. So Y must be the price of one student ticket. And now I'm going to get my highlighters out again and get through all that information. So on the first day, they sold 12 senior citizen tickets and 12 student tickets for $132. So 12 senior citizen tickets and 12 student tickets for a total of $132. And then, what's the other one? $69 for the second day by selling 6 senior citizen tickets and 7 student tickets. So 6 senior citizen tickets, so 6 times the price, plus 7 times the price of a student is $69. And it doesn't say to solve. We could. I'm just not going to ask you to solve on this review because I'm running out of time. Excuse me. Alright, next question, very similar. The question is at the end, so let's find it. It says find the number of students in each van and in each bus. So V is going to represent the number, not the number of vans, but the number of students in one van. And then B is, again, not the number of buses, it's the number of students in one bus. Alright, back to my highlighters. Here we go. High school A and B, blah, blah, blah. Alright, 2 vans, 14 buses, 594 students. So there's our first equation. 2 times the number of students in each van, plus 14 buses times the number of students in each bus. Seats 594. And then, there's another color I haven't used. There we go. High school B, build 10 vans, 1 bus for 210 students. So 10 times the number of students in a van, plus 1 times the number of students in a bus. You don't have to have the 1 there. Equals 210. And again, I don't need you to solve today on the review. We would use elimination, of course. Alright, here's the new stuff. So in this section for 1.5, you're going to have 2 tasks. You're going to have to solve excuse me, singular inequalities and then a compound inequality. So the singular inequality, we have negative 39 plus 3r less than or equal to negative 48r plus 12. And my rule is that you have to bring r's, or the variables, to the left. So we're going to add the 48r. And while we're at it, I'm going to move the constant by adding the 39. And what am I end up with here? Let's see. 51r is less than or equal to 51. Well, that kind of worked out nice. So dividing both sides by 51. Now 51 is not a negative coefficient, so you don't have to mess with the sign at all. You just say r is less than or equal to 1. That is the inequality solution. However, I also need you to graph it for me. So 1 somewhere in the number line, right? And then it says less than or equal to, so you're going to be graphing everything less than 1. And then since it says equal to, you put a bracket. So that's your graph. I need that guy too. So 1 answer, 2 answer. And then the final answer is your interval from left to right. So down here it's shading forever. So we say it starts at negative infinity and it goes until 1. And then because we used a bracket, 1 is a solution, so it's a solution down here as well. So on these questions, I'm looking for inequality, graph, and interval. This question is going to be very similar. You're going to be solving it using your equation rules, but you're going to keep your variables on the left. So negative 5 minus 5v right now is less than negative 3v plus 11. So using my weird rule about v's on the left, we're going to add 3v. And while we're at it, let's go ahead and add the 5. Helps if you can read my writing though, that's an 11. There we go. So you have negative 2v is less than 16. These are canceling. So here, when you divide both sides by a negative 2 as a coefficient, you do have to flip your sign. So this v is now greater than negative 8. So when I go to graph this, here's negative 8. I'm graphing everything greater than him, but not including him. So you're going to use a parenthesis. And then last step is to write that as an interval. Intervals always go from least to greatest, so this one starts at -8 and then goes forever to the right, which is infinity. Remember, infinities always have parentheses on them. You can't land at infinity. So once you have your 3 solutions, oops, there we go, then you are good to go on those singular inequalities. But I want to talk about these. These are those sandwich inequalities. When your variable, your algebra part, is sandwiched between 2 inequalities like this, this is really an and question. So you're going to solve for n by subtracting 10. You just got to do it everywhere. So right now we have -5 is less than, I can't read my problem anymore because I scribbled it out. -5 is less than -5n is less than 10. So you're going to divide both sides by, all 3 sides by -5, and that negative rule still applies. So you are going to have to flip your signs around. So this is a 1 is now greater than n, which is greater than -2. So if that bothers you, you can just pick this up and turn it totally around. 2 is less than n is less than 1. Oops, sorry, -2 is less than n. So either one of these are acceptable. But you have to remind yourself now, how do you graph an and? So -2 and 1 show up on the number line in that order. Ands, remember, are sandwiched between the values, so it's all the numbers between -2 and 1. And since we're not using -2 and 1, we're going to use parentheses. Alright, same thing here. You got to solve for k in the middle, so you got to do this move 3 times. We're going to add 7 everywhere. So we have -80 is less than or equal to -8k, which is less than, careful, there's not a bar there, 40. And then dividing everything by -8, I do have to flip all the signs. So you end up with +10 is now greater than or equal to k, which is greater than -5. So if you don't like the fact that it's backwards, flipsies it around. So either one of these answers is great. However, I still do need you to graph it. So all my numbers that are between -5 and 10, but this time you're going to include 10 with a bracket, but not 5. So your domain interval goes from -5 with a parenthesis and then stops at 10 with a bracket. Alright, so those were both and questions. Real quick, I don't think I have, oh I do. 2 examples of ors. I was worried. So ors are kind of weird because you just solve them separately. So it's twice the work, but whatever. Alright, so you're going to add 2. So we have what? 3n is less than or equal to -18. N is less than or equal to -6. Or you're going to add the 8 here. So 9n greater than or equal to, I can add, right? 45. Divide by 9 on both sides. N is greater than or equal to 5. So when I ask you for the inequality solution, this is what it looks like. And make sure the word or is in your solution, because otherwise it's nonsense. Now we're going to be graphing this. So make sure the numbers go in the proper order on the number line. -6 comes first because it's smaller. And I'm graphing everything less than -6, so this away. Or greater than 5, this away. And they both have brackets, it looks like. So the graph wasn't too bad, and they look like oars on a boat, which is what we kept talking about. The interval is the tricky part. So starting on the left, you have solutions from -infinity to -6 with a bracket. And then to jump over and join the other union, or the other interval, you put a union symbol, and then picks up again at 5 and goes to infinity. Infinity always has parentheses. The union symbol does not have a tail. Keep that in mind. I get really picky about that. Alright, same idea here, guys. We are solving, so when we're done, we're going to have or in our solution. Let's subtract the 3. So 10v greater than 20. So v is greater than 2. Or, I don't know why I wrote it so low, or, let's subtract 5. So we have -3v greater than or equal to 27. Now be careful here, because you're dividing by a -3, you are going to have to flip your sign. So this v is now less than or equal to -9. So this is your inequality solution. Let's see what the graph looks like. Now the number that comes first on the number line is -9. It's smaller than 2. We're graphing everything greater than 2, so 2 has a parenthesis, and then less than or equal to -9. So when I go to write out this interval starting at -infinity to -9, and then union symbol 2 to infinity. All right. One more concept real quick. We're solving absolute value equations. So the first step is to isolate the absolute value. And then after you do that, you're going to set up your two equations. So this thing right here has to be isolated completely before we do any other work. So I'm going to add the 1 over. So -10 absolute value of 5 plus x equals -40. And we're still not isolated because you got to divide by that -10 next. So absolute value of 5 plus x is 4. So here's where the two solutions come up. This stuff in the middle, 5 plus x, it could be 4, or 5 plus x could be -4. So when you solve, you get x equals -1, or x could be -9. Both are good solutions. So you got to have them both. Alright, same thing here, guys. We got to isolate these absolute value bars again before we set up our two problems. So I'm going to add the 1 over, and then still not quite isolated, we're going to go ahead and divide by 3. So I have the absolute value of r minus 4 equals 12. Now we can set up our two problems. So this stuff right here, r minus 4, it could be 12, or it could be -12. So r could be 16 when I solve that one, or r could be -8. Both are great solutions. Alright, that is the end of your summative. So a couple new scores, a couple old scores. Go ahead and capitalize on that, and best luck, best wishes.